Good evening, all of you, and today I'm going to discuss a very important concept called independent event in probability. Now, before I go and discuss it, it's better first let's have introduction to the set notation. I know all of you are already acquainted with this. Moreover, I'll come with a playlist of class 11, especially for sets, relation, and functions in a while. So let's just recapitulate so that it is enough to understand the probability game. So as you already know, any set notation is used as some x belonging to something. So an object must have some property. So here a set is given in a typical set format, which is x belongs to z integer such that x is an even number. So your set consists of all these numbers 2, 4, 6, 8 and something. Now again you can allow 0 also if you take 0 as an even number. Of course I am taking natural here into consideration. You can talk even for negative integers if you are allowing that definition. So I'm calling it as an even number, which is a natural number. This I have to enforce. Now there is something called set complement such that all x belonging to the space so that x is not belonging to the set. So suppose if this is the set, so all that remaining region is complement of set. We already know A intersection B is all that x such that x is either member of A and x is a member of both. So in a typical set notation, it will denote this common region as A intersection B. What about A union B? In set description is x such that x is a member of A or B or both. So it means A intersection B will be this entire Hurt set, right? So you can be anywhere there. Now there is something called partitioning. So let's say you have a set SA, set S. We can partition it into three sets S1, S2, S3. So basically fragmenting it is, so we are cutting it into three parts. When you are cutting it, it's very worth understanding that the intersection of S1, S2, S3 is empty, phi, and the union is yes. Okay, when we call the intersection empty, we call these sets are disjoint, means they are not joined, they are not overlapping, completely segregated. And union is set means if I take this guy S1, S2, S3, it is exhausting the entire sample space S. So we call S1, S2, S3 are exhaustive set. They are exhausting S and their common is nothing. Now sometimes JEE Advanced uses a fanciful notation of union. I belongs to integer or I. Here I am mentioning as integer. Okay, Si. So it means all x such that x is in I. Si for some I belonging to I. Similarly, intersection Si belongs to I means x such that x belongs to Si for all I belonging to I. ठीक है. अब इसको आप अगर डायग्राम के फॉर्म में समझना चाहते हो तो यू कैन टेक लेट से आई इज 1 2 3. So S1 intersection in S2 intersection S3. Let's say set A is S1, B is S2 and C is S3 according to given notation. So all common region will be here, right? Similarly, union will be this entire thing. Okay, so this is A union B union C. There is something called S minus T. So it is all x is that x is in S but not in T. So out of this total S I can take away S intersection T. Now there is two important law which is De Morgan's law. One is R intersection S union T is R intersection S union R intersection T, and R union S intersection C is R union S and R union T. अब इसको आप विजुअली भी देख सकते हो. सपोज अगर मैं R यूनियन S इंटरसेक्शन T का बात करूँ, सो S इंटरसेक्शन T जो होगा वो तो ये रीजन आ गया, राइट, दिस रीजन. And if I unite this with R, we'll get this region. So this colored region is basically R union S intersections. Now you can take R intersection S, which I have used with different colors. R intersection S is going to be this one, right? Sorry, R union S. And R union T, if I unite R with T, we are going to get this. Now if we'll take common between these two, is clearly you can see it's the same region, right? This one, which is exactly here. Okay, so diagrammatically I can say they are equal. Similarly, you can prove for the second one. Okay. Sometimes a very fanciful again symbols or notation can use. So union of S of I belongs to I complement. Okay, is intersection of I belongs to I SIC. So this is the same version of De Morgan's law in a different format. अब यहाँ पे फील करने के लिए सपोज इफ आई टेक I equals 1 into, so union of SI I belongs to 1 to 2 complement is intersection of I belongs to 1 to 2. ये क्या हो जाएगा, S1 union S2 bar is S1 bar union intersection S2 bar. Similarly for 3 we'll have SI union is SI intersection separately complement. Now you can prove this again diagrammatically, which I have shown here. If we'll take S1 union S2 means this entire region, and you take bar means the outside region, which I have hashed. Okay, that is same as S1 bar, everything except and S1, and then everything except S2, intersection part is same. The better way to dot this is not with the diagram, because diagram is attractive but less reliable in the examination hall. Up, suppose you can split into region, let's say 1 2 3 4. So now S1 union S2 is basically 1 2 3, so its conjugate is 4. S1 bar is 3 4, S2 bar is 1 4, and intersection is 4. There is another important idea which is known as Cartesian product of sets. So given two sets, we can always create a new set. It's not a new game because we are doing this in many chapters and many classes. Because given two vectors, we define two types of product, right? So we create with two vectors a new vectors using cross product called A cross B. And with two vectors, we create a new number which takes from vectors world to the real world by A dot B. Similarly, if we have two functions, we create a new functions called f of g, composition of functions or g of x, and blah blah. In the same way, given two sets, I am allowed to create a new set via something called Cartesian product. So what is S cross T? It is a set of ordered pairs of x, y, where x is coming from first set and y is coming from second set. That's what I have written here, as you can see. Let's say set S has 3 element 1 2 3 and set T has hash and star. So S cross T will definitely have corresponding to 1. We can have 1 has 1 star, 2 has 2 star, 3 has 3 star. In language of Cartesian notation, and that looks very cool, S cross T is all x comma y ordered pair, so that x belongs to S, y belongs to T. Now how this notation is going to help us in probability? Suppose if you have a coin and you toss a coin twice, or you toss two different coins once, so sample space is going to be same. So how sample space omega will be represented? It will be ht whole square. Ht whole square means it's not like a squaring ht, h square t square plus 2ht, that's bakwas. So st cross st, which gives basically 4 element h, ht, th, tt. Similarly, stq will give you, toss a coin 3 times, it will give 8 element. So in general, we are not obliged to define only Cartesian product of two sets. We can do it for general. Let's say stu is there, then we have to pick up element x from x, y from t, and z from u. Okay. A usual notation in the JE field is when you are talking about R cube, which is R cross R cross R. So it represents 3D space, and x, y, g is from any. Similarly, if I talk about R2, it represents entire 2D plane, and if it is R, it represents a real number. So I hope till here all of you understood the basic notation. Now we have something called functions also, and I'm sure like you know what is function. So function is a special relation from again two set x and y, such that every element of set x must be exhausted, okay, and no element of set x will have two images, means two connections. So let's say if you have this star, hash and half moon or something else. Okay, so this is one of the valid functions. So let's say this element 1 2 3, 1 goes to a star, 2 goes to a star, 3 goes to S is a correct functional relation. Okay, so function is a special relation where each and every member of the input set, which is x, has to be related with the codomain set. Just a recapitulation, and here range is the corresponding linkage that we are getting. So there is difference between codomain and range. You can clearly see range is a subset of codomain, either proper or improper. And you know, if range fills the codomain, we call the function as surjective. Surjective means onto. It's like your surname. If my name is something, then okay, so my surname is over my name, so it's completely filling it. Injective means 1 1, ek tir se ek nishana. Okay, like Bahubali, it cannot be a function because in Bahubali, with one bow, they have like fired 3 निशाना, तो वो भी पॉसिबल नहीं है. जैसे अगर सपोज 1 2 3 एंड कुछ हैश स्टार और समथिंग इज देयर, so we can't allow in a function one is going to a star also, one is going to, means every input will have some unique output. Okay, so this is not a function. So set theory and probability is like intimately connected, because that's the language in which basically we use a probability theory. Now you already know, like, there is some probability law. So by definition, a probability law specifies likelihood of events related to an experiment. Formally, probability law assigns to every event A a number. So let's say if we have an event A, we will associate. So probability is a function which operates from an event A to a real number 0 to 1. Okay, or maybe better language, probability is a function which assigns any event as a number 0 to 1. ठीक है, तो ये तो एक फंक्शन हो गया ना, which assigns any event as number 0 to 1. And if A and B are disjoint sets, and you know what is probability of the entire sample space, means entire universal set. Okay, anything will definitely happen in the world, that's one by axioms. This is known as normalization. Non-negativity axioms tells that probability of any event E will be greater than equal to 0. And third, if we have two disjoint events, let's say A and B, so there is no connection, so probability of A union B is probability of A plus probability of B, and this can be extended for more limits. So based on this basic axioms, a definition that probability takes sample some events and associate this with a number 0 to 1. So if probability of some event is, let's say, 0, then it is impossible. If it is 1, then it's 100% possible. And if it is anywhere between this, that's what we are interested in the chapter most. Similarly, propositions 1, you can tell if A is a subset of B, then probability of A will be a subset of probability of B. वो आप यहाँ से feel कर सकते हो. Mathematically also it can be its own, but I'm just giving you a feel of this. Let's say A is a subset of B. So happening of this is number of elements in A divided by total sample space. Happening of B is number of elements in B by sample space, provided all these happenings are equally likely, of course. Clearly you can see NA size will be lesser than NB, since it follows. In general, you know, probability of A union B, if they are not disjoint, will be probability of A plus probability of B minus probability of A intersection B by principle of inclusion exclusion. The proof of this is very obvious, because let's say A number of elements in A union B will be number of elements in A plus number in B minus number of elements in A intersection B. So when I'll divide this by sample space, तो अब आप इसको probability of A union B बोलोगे, this one becomes P of A, this becomes P of B, and this becomes P of A intersection B. Right? So in general, you can tell probability of union of AK, K equals 1. This is general principle of inclusion exclusion, is sigma minus 1 to the power K minus 1. It's very interesting to derive the result with basic combinatorics, and which I'll be doing in some combinatorics course. Is sigma of probability intersection AI with I belongs to I. You see, it looks very scary when you see in this form. At the same time, it looks you know, like attractive also, where I is belonging to 1, 2, 3 to n, and cardinality of I, number of elements in I is k. So this is the full form definition of general inclusion exclusion. ठीक है, मतलब यहाँ से what I am telling, probability of A union B union C, it decodes to P of A plus P of B plus P of C minus P of A union B, B union C, A union C, and plus P of A intersection B intersection T. So there is some union bound also, union bound. अब यहाँ से भी question has already come, and JEE Mains I have seen. Advanced I don't think till now they have given. So union bound is probability of U union of AK. Let's say K is going from 1 to n. First let me write the general theorem, is less than equal to probability of AK. K is running from 1 to n. तो अब देखो, suppose if you have a sample space in omega, let us fill this for two elements A and B, is from set A1 and A2. So it tells probability of A1 union A2 will always be less than probability of A1 plus probability of A2. अब 2 के लिए तो it is obvious. Why? Because A1 union U2 will be this region. So imagine like this area divided by total area. Okay, I'm telling when we are doing this, of course all the elements are present in, let's say, set A1 and A2. So P A1 A2 will be this one. Now what is P of A1 plus P of A2? P of A1 is going to be this region plus P of A2 is going to be this region. So if I'll add this region plus this region, this must be extra. So of course this has to be true. In the same fashion, you can see the overlapping part will be extra. So you can in fact prove it by principle of mathematical induction. Okay, so those who want to have a proof, if you want to enjoy the proof, it can be like this. It's very simple to extend it. Let's you assume it true for 1 is obvious. Okay, it's trivially true. As an inductive hypothesis, assume it's true for some n greater than or equal to 1. Okay, so if it is true for let's say till n, then we'll prove it's true for n plus 1. So it's probability of a n plus 1 union, I can write union of ak, and k is running from 1 to n. Now this you can write again, probability of Golu union Bolu, provided Golu and Bolu are sets. Okay, so it's probability of an plus 1 plus probability of union ak, not writing symbol again, minus probability of a intersection union ak, and of course k is 1 to n and k is 1 to n. So it will be less than probability of an plus 1, because this is this probability of union ak, k plus k equals 1 to n. Why? Because this quantity by probability definition, just assume I have already told is greater than or equal to 0. So out of these two positive, you are taking away something, so less than or equal to this, and this by definition is sigma p ak, k equal to 1 to n plus 1. अब देखो with the principle of mathematical induction is valid for all positive integers. ठीक है, तो ये भी एक अपर बाउंड ये प्रूव करना सही था, मतलब it's not that great. You can take some examples also, you know, like where this can be used. For example, suppose an urn contains, let's take a question. Suppose there is an urn, means vessels or bag containing 990 blue balls and let's say 10 red balls. Now 5 people each pick a ball at random, so there are 5 persons. P1, P2, P3, P4, P5. Persons cannot be same. Suppose they'll be different, even if I are twins. Okay. Now 5 persons each pick a ball at random. So there are total 1000 balls. Okay, so many balls are there, and people are picking up balls at random. We have to compute the probability that at least one person pick a red ball. Okay. You have to find the probability that at least one person, minimum one person pick a red ball. So how will you do? It's better we can, if I define the event bk denotes the event that person k draws a red ball. Let's say bk is an event such that person k draws a red ball, because the red ball can be drawn by either person 1, 2, 3, 4, 5. So what is b1? b1 means p1 draws red ball. Okay, b2 means p2 draws red ball. देखो why I am unnecessarily complicating this question by introducing set notation, because it's very trivial. Even without set notation this can be done very obviously, which I will tell you with feel. लेकिन problem is ना, every time you will not get the question in with the feel, because the question setter will put the question in set notation. So the major problem that I have seen with the students, they are not able to decode the problem completely, and once you will not understand the problem, forget about solution. ठीक है, तो इसीलिए you have to learn the concept also in the same style as JEE problem setters okay thinks of. तो उसी हिसाब से आपको पढ़ाई भी करना होगा in the same sync and so on so forth. तो यहाँ पे you can see like what is the probability that person 1, what is the probability of B1, like person 1 gets red ball. That's very easy, because there are 10 red ball and total of 1000 balls. So person first will get red ball will be 1 by 100. Similarly for all persons it will be same probability, because it doesn't matter. So probability of bk is 1 by 10 for all k equals 1, 2, 3, 4, 5. Okay. Now applying this to the bond, we can tell, suppose the probability of, suppose they are asking union bk where k is running from 1 to 5, means what is the chance, like at least one of them, यही पूछ रहा है ना. So b1 union b2 union b3 union B4 union B5. तो यहाँ से एक लोअर मीन्स बॉन्ड इवेंट्स आई कैन टेल डेफिनेटली इट विल बी सम ऑफ प्रोबेबिलिटी ऑफ बी के when at least one of them is picking red ball, k equal to 1 to 5. So it will be nothing but 1 by 10, 1 by 100 into how much? 5, which is 1 by 20. So I know the probability that at least one of them will be picking up red ball will definitely be less than or equal to 1 by 20. ठीक है. अब exact answer finding is also very obvious here, क्योंकि exactly how to find? So exactly the answer of probability that at least one of them will get red ball is 1 minus when none of them is getting red ball. Okay, so I am using De Morgan's law कि इसका conjugate क्या हो जाएगा when B1 intersection B2 intersection B3 intersection B4 and intersection B5. So probability of this, because if none of them will get red ball then definitely the remaining cases, so let's say this is the part where none of them is getting red ball, so whatever is left plus none of them getting red ball plus one of them getting red ball plus exactly two of them getting red ball plus exactly three of them plus exactly four of them plus exactly five of them, we will make up fill up the entire sample space because that is the only exhaustive possibilities. तो इसलिए 1 minus 1 निकाल देंगे, आंसर आ जाएगा. अब बताओ B1 इज गेटिंग रेड बॉल, उसका क्या चांस है, मतलब B1 को रेड बॉल नहीं मिले, इसका क्या चांस है. सिमिलरली B2 को नहीं मिले, B3 को नहीं मिले, B4 को नहीं मिले, B5 को नहीं मिले. Okay, so there are many ways of doing. I'll not use like one way of doing is if B1 is not getting red ball, right? So suppose how many red balls are there? There are 10 red balls and 990 in that ball. Okay, so then you can tell it will be 990 by let's say 1000 if I take. Now suppose B2 should also not get red ball. So if I'm taking 990 by 1000, okay, so like this if I multiply 5 times 990 by 1000, will I get the answer? Will I get the answer? अब देखो this is not the correct answer. क्यों? क्योंकि यहाँ पे question is different. Question is we wish to compute probability that at least one person picks a ball. 5% each picks a ball at random without replacement. Okay, so randomly 5 persons have picked a ball at once. तो अब सैम्पल स्पेस क्या है, अब सैम्पल स्पेस क्या है फर्स्ट के लिए, it's 100 100 100. So because right now if I want to multiply this probability, it means I need a rule where I can use B1 intersection B2 as probability of B1 into probability of B2. Now here some of you who is watching video will tell yes sir it's independent, hence I can use, because till now I have not discussed under what condition this will be used. Okay, so I'm assuming this lecture is the first in course and especially like don't assume anything if you have not read till now. Okay, तो यहाँ से still there is a way, because I know out of 1000 any 5 ball could have been taken by those 5 persons. ठीक है, let's say if you name the ball B1 B2 till B1000, so any 5 ball they could have taken. अब 5 ball में that 5 ball should not be red, that will be 990 C5, right? So this probability will come as 990 C5, because in this way that 5% will definitely not pick red ball, divided by total possibilities, the sample space of picking red ball is 1000 C5. So 1 minus this is the answer, and this if we will calculate it will be approximately 0.0491. this I have already calculated. और आप देख सकते हो ये जो लोअर बॉन्ड है इट्स अराउंड 0.5. okay, so it will be 0.049 is definitely less than 0.5, but you see the window is quite close. So the point is why this like the upper bound is helpful in some case, because it helps you to get the answer quick. Maybe if options are not made nicely, then you can do it in a nicer way, right? As a second application, you can also consider the same problem where 5 people each draws 2 balls from the urn without replacement. Okay, suppose 5 people, each of them draws 2 balls from the urn without replacement. This time again we wish to approximately find probability of at least one person getting 2 red ball. अब using the same step, what we'll do for this part B, if a person takes 2 ball, so again probability of union CK, let's define CK as the event when person 1 gets at least 2 ball, because B I am defining for exactly, so it will be less than equal to probability of CK sigma k equals 1 to 5. Now this quantity again, I can tell it will be less than equal to k equal to 1 to 5. Now two of them should pick red ball, like one person should pick 2 red balls. I wrote 10 red balls. I need to divide by out of 1000. He could have picked any two. So it's 10c2 by 1000c2, and this summation comes to be 1 by 2220. So you see, still you got the bound, because calculating the exact value here now will include inclusion exclusion principle, and that's challenging. But you already know a threshold to it. So maybe if JEE wala set some questions where threshold is known to you, आप आसानी से उसको कर पाओगे. Clear? Now there is something called finite simple space, because in our syllabus we'll be dealing with finite simple space. Okay. Now there are two simple space which is like important for our JEE course. One is countably infinite, and other is finite. Now what is, I'll define both of them. So what is finite simple space? Let's say if a simple space, if I denote with omega. Acha, before this let me still take away this confusion. अब अगर कोई बच्चा सपोज ऐसा सोच रहा है जो सर यहाँ पे 990/1000 करके आपने मल्टीप्लाई क्यों नहीं किया, क्योंकि मैं फर्स्ट बॉल अगर निकाल रहा हूँ, सपोज पर्सन इज पिकिंग फर्स्ट बॉल, सो ही विल गेट 990/1000, राइट. अब पर्सन 2 इज सेकेंड गेटिंग द फर्स्ट बॉल, इट्स 990/1000. अब ये गलत है, कॉन्सेप्चुअली गलत है, क्योंकि देखो 5 पर्सन इज साइमल्टेनियसली पिकिंग अप बॉल. ठीक है, तो सेकेंड पर्सन के लिए तो वो तो एक साथ निकाल रहा है ना, तो अब एक साथ निकाल रहा है. इफ दिस इवेंट इज हैपनिंग इन सक्सेशन, तो फॉर फर्स्ट पर्सन number of non-red ball will be 990 out of 1000. For second person, now number of balls available is 999 only. ठीक है, so sample space is changed. For third person is 998 only. मतलब समझ रहे हो ना. So still you can see like this, like first person के लिए तो 990/1000 था, but the moment some ball is in hand, so for other person it's 999 ball. ठीक है. Now what is the chance that the ball that he has drawn is non-red? That depends upon what ball this person has drawn, the first person has drawn. मतलब समझ रहे हो ना, क्योंकि अगर फर्स्ट पर्सन रेड अगर एक बॉल ले लिया तब तो नंबर ऑफ रेड इज 9, तो स्टिल द नंबर ऑफ नॉन रेड इज 990. बट इफ द फर्स्ट पर्सन हैज टेकन नॉन रेड देन इट विल चेंज. इसका मतलब द नेक्स्ट इवेंट विल बी डिपेंडेंट ऑन द फर्स्ट. सो हियर b1 b2 b3 b4 b5 इज नॉट इंडिपेंडेंट इवेंट, हेंस यू कैनॉट मल्टीप्लाई ब्लाइंडली. ओके. Now again I have used the word dependent and independent. It feels like right now call me crazy, okay, and just ignore it. So I hope you have explained this. So I'll very in a systematic way will tell you what exactly independent and independence means. So what is finite simple space? If a simple space omega contains a finite number of elements, then the probability law on omega is completely determined by probability of its individual outcomes. So let's say if I denote a simple space omega as S1 S2, this is finite simple space, FSS, finite S1 S2 S3, and suppose this is the outcome of the simple space. The best example is dice throwing and tossing up a coin. So dice will show the simple space of dice will be 1 2 3 4 5 6, standard 6 face dice, unbiased, and for coin it will be tail or head. Okay, so these are examples of finite simple space. Now any event in omega, if the form of any event A will be in the form of Si belongs to that omega such that I belongs to integer. ठीक है, तो hence probability of A will be nothing but probability of Si belongs to omega such that I belongs to integer. Let's use curly bracket as set notation, and that becomes simply sigma of probability of Xi I belongs to integer. मतलब probability of 1 and 2 अगर एक साथ आएगा, so it's probability of 1 plus probability of 2. Okay. So in this sense, in addition, if the elements are equally likely, so this is valid for as a general case. But if elements are equally likely, it means let's say head and tail chance is equal. Elements are equally likely. Equally likely means there is no discrimination between picking up or rejecting any of the element. Then under this case, this general distribution boils down to probability of A as number of elements in A divided by total number of elements in set. Because P of S1, P of S2 all this becomes till P of Sn becomes 1 by n, because they have one contribution out of n contribution. So under that condition, the probability becomes takes up this one. I hope it is clear, and very clearly I have mentioned it. What does it mean? For example, let's take a small example of rolling a fair dice as an experiment with finite number of equally likely outcome. तो probability of observing any of the face level to क्या हो जाएगा 1/6 हो जाएगा, क्योंकि dice will show 1 2 3 4 5 6. अब देखो दिस इज वेरी ट्रिवियल, लेकिन आप समझो जो किस कंडीशन में वो 1/6 हो रहा है. ठीक है. सो ऑन द सैंपल स्पेस नाउ गेटिंग 1 2 3 4 5 6 is equally likely. Okay, hence probability of any event will be 1/6. Probability of getting 1 will be 1/6 and so on. Now if I define an event of probability of getting 2 3 5, then what will be the probability? Is simply probability of getting 2 plus probability of getting 3 plus probability of getting 5, which is 3/6, which is 1/2. The other is countably infinite models. Recently JEE Advanced has asked many questions. वो GP type का question probability, which is based on countably infinite models. What is countably infinite models? Again, consider a sample space that has countably infinite number of elements. Means still is discrete element, like number of elements is infinity. Because continuous probability is not in the syllabus, I will not deal with that. तो ऐसे Sn है, Sn plus 1 है, ठीक है, Sn plus 2 है, and it's going till infinity. We use the sign infinity for no beginning, no end, no middle. That's why usually we use 3 dots. Okay, by the way. Again, probability law and omega is specified by probability of individual outcomes. अब again the probability law is specified by individual outcomes. So probability of A, फिर से I'll write probability of some Sj belonging to that simple space such that J belongs to J. ठीक है. J is a subset of positive integers. Suppose if I tell J is a subset of positive integers. I plus. Okay, so that basically amounts to again probability of Sj such that J belongs to J, subset of positive. Now here I am not writing 1 2 3 4. You see the smartness in this set notation. The smartness in set notation is because 1 2 3 4 infinite can come. You must have solved problems like okay, like 2 players are playing a game for the first time and get a 6, they'll win the game or lose the game. These kind of problems falls in this category. The possibly infinite sum is always convergent series. Okay, अब जैसे P of Sj जो मिलने वाला है आपको when J belongs to J, तो this is always a convergent series. क्योंकि ये डाइवर्जेंट होगा तो फिर मीनिंग ही नहीं है क्वेश्चंस का. Right, and the summands are of course non-negative and sum is bounded above by 1. It is consequently well defined. Let's take one example to have a feel of that. So again एक question कर लेते हैं. Suppose that a fair coin is tossed repeatedly. So you have a fair coin, so you know like the outcome is head and tail, and you are repeatedly tossing it until head is observed. The number of coin tosses is recorded as the outcome of this experiment. A natural sample space will be what? 1 2 3 4 5 6. So what is outcome? Outcome of this event that has to be well defined. It's number of coin tosses. So the question is, if you toss up a fair coin repeatedly until head is observed, so what are the possibilities? So let's experiment. Feel. So suppose एक तो first time में I toss and head I got, or it might possible first time I got tail and then I'll get head and then I'll stop the experiment. You have to keep on tossing until you get head, or first I'll get tail. अब tail आया तो फिर से एक बार उछालना होगा tail, and then let's say head came. Okay, or tail head and so on and so forth. I hope now you got tail head, or maybe tail and then head. So it will keep on going because it might happen like I'll take trillions and trillions of years to get ahead. Although its chance is very low, but still it's possible. It's one of the possible case. Imagine if I am so unlucky. Okay. So this sample space number of coin tosses will be what? Either I have to toss once or twice or 3 times or 4 times or 5 times or 6 times. आप देख रहे हो ना? This set में how many number of coin tosses are there? Infinitely many. If I ask you what is the probability of observing head on the first trial, so in the first trial, so what is the probability of getting, head on the first trial? The first trial meant it's half because getting head is 1/2. Probability of getting head in the second trial, That is interesting. So probability of getting head in the second trial. 2 means second trial. PK I am defining probability of getting head in kth trial. अब देखो second trial means basically you have a coin. So coin will show either head, tail, tail or tail head. Now out of this, what is the chance like we got tail head? Okay, so it's basically 1 out of 4 because all these are equally likely because I have used this statement, see, very silently, because all these are equally likely. तो ये खतरनाक statement, that is 1/4. अब some of you can also tell like probability of tail and head because in first trial probability of getting tail is half, second trial and again it's half, so let's multiply. So I'm not doing this as of now because under what case we can multiply or we cannot, that will be taken as a part of dependent and independent event. अब यहाँ पे आप कर सकते हो for information, क्योंकि imagine like first you got tail, so that chance is half, again you should get head, that chance is also half. So now you should be too much lucky, you know, like very lucky to get tail and then followed by head. It means your chance of getting tail with head should decrease. You should be too lucky to get tail head. It means this chance logically should be less than just chance of getting head, right? So if chance of getting head is 50%, chance of getting tail after head must be less than 50%. So it's exactly 25%. Okay. Okay, you have 4 possibilities. If TTH, since now there are more possible combinations, out of this you want only TTH, so 1 out of more combinations, chances further decrease, so it will be 1/8. इस केस में क्या होगा probability? तो इस केस में probability क्या होगा? इस केस में probability देखो कितना आसान आ जाएगा. So probability of getting head in 1 trial or head in 2 trial or head in 3 trial and so on and so forth. It's just probability of getting head in first trial plus probability of getting head in second trial. This is a general rule. Now first trial I'm getting 1/2, second trial 1/4, third trial 1/8 and so on. It is GP, so half by 1 minus R, which is 1. Now this is obvious. It means it's 100% sure. Like sometimes head will definitely come. That's what obviously it is. Because if you keep on doing, okay, what I have found is what is the probability of observing head. So of course it will be 100%. What is the probability of observing head in the third trial? That will be 1/8. I hope it makes sense. Similarly, probability of number of coin tosses being even. Okay. So suppose in how many even tosses you will get head. तो अब वो तो है क्योंकि even toss के लिए first tail and head should come. So now we will have a new sample space. Okay. Now tail head will come because now we have 4 toss, 2 toss, tail head. So we have 6 toss and so on and so forth. So its probability of getting head in 2 or 4 or 6 and so on is basically 1/4 times 1/1 minus 1/4. Again it is a GP series, so it's 1/3, which was again expected. क्योंकि देखो probability of getting head in even toss is 1/3 and probability of getting head in odd toss then it will be 2/3. Now why do you feel this probability is different? ठीक है, क्योंकि देखो first time if suppose someone tossed the coin and he gets tail, so that will not be included in this sample, but first time someone tosses the coin and he gets head, तो उसका चांस हो जाता है ना 50%. It means the probability of getting head in the odd toss is biased because first time only you can get head. Okay, तो इसीलिए this probability is logically again more than that, in fact twice as larger than this. अब here there can be another question also. They can ask you find the expectation of number of head. Expectation means mean of number of head. तो अब ये भी आपको पता होगा कैसे फाइंड करते हैं. सपोज फर्स्ट एक्सपेरिमेंट में इफ आई वांट एक्सपेक्टेशन ऑफ नंबर ऑफ हेड्स such that the game stops when you get head as the flip. तो अब देखो, अब suppose first only head is there, then 1 head and the probability of getting 1 head, plus in 2 times you got head, so 2 times probability of getting 2 head, again 3 times probability of getting 3 head, 4 times probability of getting 4 head, and so on. So this is expectation. What is expectation? Expectation of number of head means number of heads times probability of getting that number. Okay, and that sigma is basically expectation. तो ये हो जाएगा x times p of xi sigma I belongs to that set of positive integers. So again it will be infinite series क्योंकि यहाँ पे mean number of tosses such that you will get a head. तो यहाँ पे क्या आ जाएगा, देखो 1 times probability of 1/2 plus 2 times 1 by 2 a square plus 3 times 2 cube plus 4 times 2 4. Now this is AGP series. अब इस AGP सीरीज को आप सॉल्व कर सकते हो. X equals 1 by 2 plus 2 by 2 a square plus 3 by 2 cube. How to solve? You divide by or multiply by half. That's a very standard format of solving this. 1 by 2 a square, 2 by 2 cube and so on. Now beautifully you can subtract it because AGP series is nothing but can be converted into GP. So it will be half plus 2 by 2 a square minus 1 by 2 a square. Just still half. This will become 1 by 2 a square. Next is 1 by 2 cube and so on. We know till here the answer is already 1. So it's 3 by 2. 3 cancel, x equal to 3. Now what is the significance of this? So the expectation of number of heads such that the experiment ends while getting the first head will be 3. इसका मतलब almost 3 times अगर ऐसा करोगे, roughly 3 times is the average value of getting number of, okay, like flip of coin to get 3, to get head. Now again there is some uncountably infinite models. So when we have, let's say, if ABC is taken from this window, suppose you have 3 numbers, ABC is taken from 0 to 1, what is the probability that these segments will form a cyclic quadrilateral? So these kind of questions, of course it's not in your JEE syllabus, I will not be discussing this. So this is uncountably infinite models. So that is not our part of syllabus. So that will do. In the next class, I'll give you introduction to independent and dependent event, and via that we'll go to Bayes theorem and a lot of problem solving, and I think that's enough for probability. Okay.